Without these key achievements, the Roman state would never have risen to its greatness. Its dominion over a significant part of the world was due not only to the fearlessness of the legionaries but also to unique military technologies. The main secret of their triumphs was groundbreaking weaponry that gave the Romans an undeniable advantage over any opponents. While other peoples fought with primitive clubs and swords, Roman engineers created deadly devices. These inventions fundamentally changed the nature of warfare, laying the foundation for future strategies for centuries to come. Today, we will examine 7 types of weapons without which the scale of the Roman Empire would have been unimaginable. Be sure to watch until the end, as the last of them turned out to be so powerful that even the Romans themselves were wary of using it. The first and truly revolutionary weapon that changed the course of war history was undoubtedly the Roman Gladius. This short sword, inspired by Celtic models, marked a revolution in tactical armament. It was adopted around the beginning of the 2nd century BC, quickly displacing longer and more outdated types of swords. The length of its blade was usually from 67 to 75 centimeters, and the width at the base reached 5 centimeters. Thanks to its design, short, heavy, balanced at the hilt, and pointed, it was ideal for quick thrusting in close combat. This characteristic made it extremely effective in the hands of a trained legionary. The essence of the Gladius's design lay in its specific sharpening for thrusting, rather than wide slashing blows. Swords of other peoples required significant space for a swing, whereas the Gladius allowed for precise and rapid lunges even in confined conditions. The sharp tip of the blade easily pierced armor and shields, minimizing the opponent's chances of defense. The metallurgy used in its production was advanced for its time. Roman blacksmiths used forging techniques that provided the blade with both strength and flexibility. The central part of the sword was softer for better resistance to loads, while the cutting edges were tempered, which ensured their sharpness and durability. Thanks to this technology, the Gladius became a reliable tool capable of withstanding numerous battles. The process of making a Gladius was labor-intensive and required high precision. The iron and steel blank was repeatedly forged so that the master could achieve uniformity of the blade structure and eliminate weak spots. The final tempering was carried out under strictly defined conditions, which ensured strength and the retention of the blade's sharpness even after prolonged use. The metallic pommel served as a counterweight to the blade, providing the legionary with a confident grip and the ability to deliver quick and precise blows without unnecessary effort. The scabbard for the Gladius was a separate engineering solution. It was made of wood, covered with leather, and reinforced with metal plates. The fastening system allowed the sword to be worn on the right side, leaving the left hand free for the shield, which ensured ideal combat readiness. The Gladius could be drawn and put into action instantly. The combat tactics with the Gladius differed significantly from the methods familiar to other peoples. Roman legionaries did not swing their swords but used short thrusting movements, covering themselves with large shields. This approach required minimal space and was deadly effective in close combat. Opponents accustomed to wide swings simply did not have time to react to the rapid and precise lunges of the Romans. Training in the use of the Gladius was a key element of Roman soldier training. Recruits trained for months on straw dummies, practicing each blow to automaticity. Every lunge had to be precise and deadly, without unnecessary movements. After all, in battle, life and death were decided in fractions of a second. The psychological effect of the Gladius was no less important than its physical parameters. Barbarians, accustomed to long skirmishes and sweeping blows, were amazed by how quickly and organizedly the Romans acted in formation. One precise thrust could end a fight before the opponent even realized what had happened. There were several modifications of the Gladius, each adapted to specific conditions. An early large version was the Gladius Hispaniensis, with a long leaf-shaped blade and an elongated tip designed for piercing armor and delivering powerful thrusting and slashing blows. Later, the Mainz and Pompey types became widespread. The Mainz type was distinguished by a more pronounced waist and an acutely triangular tip, while the Pompey type, which appeared later and became the most common in the imperial period, had straight parallel edges and a shorter working part, making it particularly convenient for rapid thrusting blows in a dense formation. Later, by the end of the 1st century AD, a longer Celtic sword known as the spatha became widespread in the Roman army. It found wide application in cavalry and gradually replaced the Gladius in heavy infantry due to its increased range. Supplying the army with weapons was a systemic element of Roman military doctrine. Vast reserves of blades were always kept in the Empire's armories, allowing for the rapid arming of new units and replenishment of losses after military campaigns. Standardization of parameters and production methods ensured similar weapon quality among different soldiers, increasing the overall combat effectiveness and efficiency of the troops. The impact of the Gladius on military strategy is invaluable. It ensured Rome's dominance in close combat for centuries and became the basis for a series of subsequent short blades within the European tradition. The idea of a short thrusting sword was later adopted by European armies, and the fundamental principles of its construction are still used in the basis of many combat knives today. The second revolutionary weapon of the Romans was the pilum, a throwing spear that significantly changed the strategy of infantry battles. Unlike the primitive throwing spears of other peoples, the pilum had a carefully thought-out design. The total length of a typical pilum was approximately 2 m. Of this, about a meter was the wooden shaft, and the metal part occupied approximately 0.6 m. These proportions could vary on different specimens. The key feature of its design was a narrow iron neck and a conical or pyramidal head. In some examples, the neck was made thin and less hardened, so upon contact, it deformed or broke, making it difficult to extract and disabling the enemy's shield. However, not all archaeological data indicates intentional weakening of the neck for bending. Fully hardened variants were also found, capable of retaining strength and used in close combat. The effectiveness of the pilum was determined, not by the maximum throwing distance but by its ability to disrupt formations and pierce enemy shields. The Romans threw pila at a relatively short distance, usually in the range of 15 to 20 m, to have a high probability of piercing shields and hitting a warrior hidden behind them. Standard tactics involved a massive volley of pila before the start of hand-to-hand combat. A legionary could carry 2 pila, sometimes differing in weight, throwing them one after another or both at once to weaken and demoralize the enemy, after which he would advance with his gladius. The mass and design of pila were not standardized. Both lighter and heavier specimens existed. Lighter ones were convenient for throwing several tens of meters, while heavier ones provided greater penetration at close range. Such a volley inflicted not only physical but also powerful psychological damage. Pierced shields, weighed down by darts, lost their functionality. Enemy battle lines were disrupted, and many warriors were wounded, even before direct engagement. Roman armories established mass production of pila and standardized their main components, ensuring uninterrupted supply to the legions during military campaigns. There were also modifications of the pilum with reinforced heads for piercing heavy armor, with altered neck shapes, and with various types of fastening for the metal part to the shaft. All these variations reflected the development of the weapon and its adaptation to specific combat tasks. What diversity made the pilum a universal tool that could be adapted to various combat conditions. Archaeological finds confirm the widespread distribution of these throwing spears. Thousands of iron tips are regularly found at ancient battle sites. Historical chronicles mention that in the Battle of the Allia alone, the Romans threw tens, possibly hundreds of thousands of darts, creating a practically impassable wall of iron that rained down on the enemy's heads. The significance of the pilum in military history cannot be overstated. It became the prototype of a weapon that was impossible to use against its creators and embodied the idea of a single-use strike that makes the enemy vulnerable. This concept, originating in antiquity, has endured through the centuries and in adapted form, was used in military technology, even in modern times when weapon systems with a similar principle of operation were created. Thus, the pilum was not just a spear but a means of tactical superiority that made the Roman army even more invincible. It disrupted enemy formations, deprived them of protection, undermined morale, and paved the way for triumph. The third important weapon of the Romans was the scutum, a large rectangular shield that turned legionaries into peculiar mobile fortresses. Unlike the round or oval shields used by other peoples, the scutum was an integral part of a cohesive defensive system around which the entire tactics of the Roman army were built. It performed many functions, provided protection, could serve as a striking tool, and allowed for the formation of dense battle formations that made the Roman legion virtually invincible. The dimensions of this shield were quite impressive, about 120 centimeters in height and 77 centimeters in width, which fully covered the soldier from head to knees. The convex shape evenly distributed the impact energy, thereby reducing the likelihood of penetration. Its construction was meticulously thought out. Thin wooden slats, consisting of 3 layers, were firmly glued crosswise, contributing to both strength and lightness of construction. Its mass was approximately 6 kilograms. The outer surface of the wood was covered with leather, and the edges were reinforced with metal trim. In the center was a massive umbo, a metallic convex part that served as both protection and an offensive element. The handle passed behind the umbo, which ensured a comfortable grip and the possibility of using the shield as a battering ram. The lower edge of the shield was also used to strike opponents' legs. The scutum not only defended, but also attacked. Shields were painted, and their surfaces were decorated with legionary symbols, including eagles, lightning bolts, and unit names. Bright painting increased the combat spirit of the Romans and terrified their opponents. Thousands of identical shields formed a continuous red or golden monolith. According to tactics, the shield was held in the left hand, and the gladius in the right delivered blows through the gaps. This turned the Romans into a single, cohesive mechanism. The continuous line of shields provided protection to the formation, and the blades protruding from behind them struck the enemy. The most famous formation was called the tortoise. Legionaries raised their shields in front of them, to the sides, and above their heads, creating an almost impenetrable dome. Such protection allowed them to approach fortresses without the threat of arrows, stones, or spears. Training of recruits began from the first days. They became accustomed to the weight of the shield, mastered the correct stance and movement, using weighted training shields to increase strength and endurance, and also learned to strike with the umbo and act in coordination with their comrades. The production of scuta required high skill and significant time investment. Highly qualified craftsmen selected wood, carried out the gluing of layers, reinforced edges with metal, covered with leather, and painted the surface. Each shield was made over several weeks, which was a laborious process, and served as a means of defense, attack, and a symbol of Roman military power. At the same time, hundreds and thousands of identical scuta were produced in warehouses, so that each legionary had reliable protection. Care for the scutum was a direct duty of every soldier. Shields were regularly lubricated with oil to prevent the leather from drying out and cracking. Fastenings were tightened, damage was immediately repaired, and the paintwork was renewed before military campaigns. The loss of a shield was considered a very serious offense. It was as important as the sword, as without it, the legionary became completely defenseless. The evolution of the scutum proceeded in accordance with changes in Roman military tactics. Early variants were oval and light, giving greater freedom of movement. Later, as the army focused on dense defensive formations, shields became rectangular and more massive. For cavalry, smaller round versions were created, convenient for carrying in the saddle. The scutum had a significant impact on military history, serving as a model for many armies of antiquity and the Middle Ages. Large rectangular shields were used by knights and infantry in Europe. Today's police shields, used for riot control, continue to rely on the same principles of protection and organization as the legendary Roman scutum. Therefore, the scutum was not just a shield. It represented the foundation of the Roman war machine, a symbol of order and the might of the legions. This shield united soldiers into a single, unbreakable formation, where everyone felt part of a mighty army, and enemies faced a mobile fortress that was practically impossible to overcome. The fourth revolutionary weapon of the Romans was the ballistae, a torsion catapult that became the precursor to all subsequent artillery. For its time, it was a weapon of unprecedented power and accuracy. A ballista could hit targets at a distance of up to half a kilometer, and its accuracy amazed contemporaries. Hitting an individual or even a specific commander was not considered an accident but an expected result. Therefore, the ballista is often compared to the sniper rifle of the ancient world. Its principle of operation was based on the energy of twisted animal tendons or hair, which served as springs. Two torsion springs, mounted horizontally in a sturdy frame, accumulated incredible force. When the levers were activated, this force was transferred to the bowstring and instantly released at the moment of firing, imparting colossal speed to the arrow or stone. This system significantly surpassed any bow or crossbow of that period in power. The idea of using twisted cords proved so successful that torsion machines were used for over 1,000 years. The construction of a ballista was a complex engineering system. A wooden frame held metal components and torsion springs. Levers provided tension, and a system of pulleys and latches allowed for relatively quick loading of the machine. Operation required high precision, Uneven distribution of force in the torsion springs could lead to projectile deviation or even damage to the ballista. The production of a single ballista took weeks and required the participation of a whole group of specialists, including carpenters, blacksmiths, and rope makers. The ballista was not just a weapon but a true work of engineering art. Projectiles for such a device were diverse. Their selection depended on the specific circumstances. Long arrows, exceeding a meter in length, were often used. These, fired with tremendous speed, easily pierced shields and armor, destroying the enemy at a distance of many hundreds of meters. But ballistae could also launch stone balls weighing up to several tens of kilograms, capable of collapsing walls, towers, and various fortifications. There were also incendiary projectiles, arrows with flaming tips, intended for igniting wooden structures or enemy siege engines. The accuracy of the ballista's firing was impressive even to allies. Experienced crews easily hit man-sized targets at distances of hundreds of meters. There are preserved accounts that during sieges, Roman commanders deliberately gave orders to aim ballistae at enemy commanders, officers, and standard-bearers. The death of a leader at the beginning of a battle caused panic, undermined morale, and often determined the outcome of the entire confrontation. The firing rate of a ballista was approximately 1 to 2 shots per minute. This was significantly inferior to the capabilities of archers, but it was fully compensated for by the incredible power and range of destruction. In terms of effectiveness, one ballista could replace more than a dozen archers, and the simultaneous use of dozens of such machines turned the battlefield or fortress walls into a true hell. For the enemy, there were several types of ballistae. Among them were light portable models, nicknamed scorpions, weighing about 50 kilograms and could be mounted directly in position. They were used for accurate fire on the enemy at medium distances. Heavy siege ballistae, weighing up to a ton or more, were transported exclusively disassembled and assembled at the walls of besieged fortresses. These installations fired stone projectiles and served as siege artillery for the destruction of walls and towers. The crew of a ballista usually consisted of 3 to 4 people, each performing their duty. One soldier gave commands, performed aiming, and determined the moment of firing. Another soldier loaded the projectile and activated the firing mechanism. The remaining crew members delivered ammunition, serviced the machine, and, as needed, repaired damaged parts. Only the coordinated work of the entire crew ensured continuous fire. Training to operate a ballista lasted several months. Soldiers thoroughly studied the machine's design and learned to accurately calculate distances, taking into account wind corrections and elevation angles. It was vital for them to load the weapon quickly and safely, and also to correctly distribute effort when tensioning the torsion springs to avoid damaging the mechanism. Unlike individual weapons, the ballista required collective work and strict discipline, making it not only a means of destruction but also a symbol of organization. Transporting ballistae was a separate, complex task. The machines were disassembled, then transported on carts, and reassembled directly on the battlefield. Experienced soldiers could assemble and bring it to combat readiness in half an hour or an hour, but it still required time, tools, and a reliable shelter. Therefore, ballistae were usually used either in advance during siege preparations or as support in large battles. The tactical use of ballistae was diverse. In open field engagements, they struck enemy formations and commanders, disrupting their ranks and undermining their morale. During sieges, ballistae destroyed enemy walls and fortified towers, creating breaches and eliminating defenders on the ramparts. In defensive battles, they controlled approaches to cities or camps, preventing enemy advance. The production of ballistae was carried out in specialized workshops, as their creation required not only materials but also deep knowledge in mechanics and mathematics. The cost of one such machine was enormous, comparable to the annual salary of senior officers. Therefore, ballistae were valued at their weight in gold, and each of them became a strategic weapon capable of deciding the outcome of an entire campaign. The influence of ballistae on warfare was truly significant. They became the basis for the development of all siege and long-range technology in Europe and Asia. The principles of torsion construction were used until the early Middle Ages, and then evolved into trebuchets, catapults, and early cannons. It can be argued that modern artillery originated from the Roman ballista, which first demonstrated to the world the power of long-range projectile weapons. Thus, the ballista became not just a tool but a symbol of Roman engineering, genius, and discipline, proving that technology can be as decisive in war as the courage of a warrior. It was the ballista that paved the way for the creation of artillery, which forever changed the course of history. The fifth weapon that changed the course of war was the catapult, a heavy siege engine for throwing stone projectiles. This was the true weapon of mass destruction of antiquity, designed not for duels or single attacks, but for the systematic destruction of fortresses and fortifications. Cities whose defensive walls seemed unshakable soon realized their vulnerability with the approach of Roman catapults. These engines transformed powerful fortifications into ruins, and the morale of the defenders was reduced to complete despair. Roman engineers, developing ideas borrowed from Greek models, significantly modernized them. They achieved reinforcement of torsion mechanisms, increased the size and power characteristics of the machines, integrated more reliable components, and developed a high-precision aiming system. Thanks to these improvements, Roman catapults ceased to be mere throwing installations, turning into formidable engineering war machines with destructive power previously non-existent. The largest examples of such catapults could launch stone projectiles weighing tens of kilograms to a distance of up to 400 m. These stones, flying with the speed of a whirlwind, pierced walls up to 2 meters thick, destroyed towers, and broke down gates. One hit was enough to create a breach several meters wide, through which legionaries could rush to storm the fortress. Even if the walls remained intact, the constant attacks instilled terror in the defenders and gradually depleted their strength. The construction of a catapult represented complex inventions of engineering thought. A wooden frame up to 4 m high contained giant torsions, twisted bundles of ropes or fibers, accumulating energy. Through a system of levers and pulleys, the machine, weighing several tons, could be cocked by the effort of 1 to 2 people. The entire mechanism worked on the principle of accumulating and instantly releasing energy, which gave each shot incredible power. Projectiles for catapults were made with special care. Stone balls were carved from durable rocks such as granite or basalt. To increase the destructive effect, they were given an irregular shape with sharp edges that effectively destroyed walls upon impact. Some projectiles were made in halves and filled with incendiary mixtures. Upon impact, such stones exploded, causing fires inside the fortress. This made the catapult not only a means of physical destruction but also an instrument of psychological pressure. The Romans constantly improved the accuracy of their catapults. Engineers developed devices for measuring angles in the aiming system, and also created special tables for accounting for wind force and distance. Experienced operator teams could hit fortress gates or individual towers from a distance of several hundred meters. Sometimes commanders deliberately ordered fire on crowds of people, which inflicted enormous damage on the defenders. The psychological impact of catapults was no less significant than their physical effectiveness. Giant boulders, cutting through the air with a whistle and crashing into the walls, caused panic among the defenders. Ominous roars, clouds of dust, and collapsing towers, all of this undermined their will to resist. Many cities capitulated to the Romans even before the main assault began. I imagine rows of heavy catapults being set up. There were several types of throwing devices. Light engines were used in field conditions for shelling troops and marching camps. More powerful constructions were used during sieges to destroy walls. Ballistae and catapults often worked in tandem. The former struck pinpoint targets, while the latter destroyed fortifications. Over time, even larger machines appeared, becoming precursors to medieval trebuchets. Such diversity allowed the Roman army to effectively solve a wide range of tasks on the battlefield. Operating a catapult required the coordinated work of a team of 8 to 12 people. The gun commander was responsible for aiming and selecting targets, while other crew members loaded projectiles, operated the levers, checked the torsions, and monitored the condition of all units. The work was physically demanding and associated with risk. In case of error, the machine could malfunction or injure soldiers. Ensuring a steady supply of ammunition for the catapults was a separate problem. Thousands of stone projectiles were required for a prolonged siege. Up to 500 tons of ammunition could be expended over several months of siege. Stones were mined in nearby quarries or transported from afar, which required significant logistical effort. Setting up catapults in positions was a serious engineering task. They were placed on specially prepared platforms, reinforced with supports, and protected by shields from enemy projectiles. Free space was left between the catapults, so that they did not interfere with each other and could maintain continuous fire. Sometimes the engines were placed on earthen ramparts to increase the firing range and optimal impact angle on the walls. Methods for protection against catapult fire were also developed. Defenders erected wooden screens and covered the walls with wet skins to reduce the impact force and prevent ignition. Sometimes they dug underground tunnels to destroy the positions of siege engines or set them on fire from below. However, in most cases, catapults still brought success to the besiegers. The evolution of catapults continued for many centuries. Subsequently, Roman machines were equipped with metal elements, more complex aiming mechanisms, and standardized parts. Some catapults were collapsible and transported on wheels, which significantly accelerated their deployment during military campaigns. Gradually, these machines became a key element of all siege artillery, both in antiquity and in the Middle Ages. The impact of catapults on military development was colossal. They embodied the technical power of Roman engineering thought and anticipated future artillery systems. The principles underlying Roman catapults were exploited until the invention of the first gunpowder weapons. Modern howitzers and cannons can rightfully be considered descendants of these ancient devices, which first demonstrated the power of long-range weaponry to radically change the course of military campaigns. Thus, the catapult became an instrument that transformed the very essence of warfare. It stripped walls of their invincibility, left cities defenseless, and turned Roman legions into a truly invincible force. The sixth element of Roman military superiority was not only a sharp blade or a throwing machine but also engineering thinking itself. The mobile fortified camp, the castrum. It was this solution that allowed the legion to turn any terrain into an impregnable fortress in a matter of hours. The Romans realized that success in war was determined not only by direct clashes but also by how the army was organized in movement, in quarters, and in defense. Castra formed the basis of this system. Every day after the march, the legion transformed a field, plain, or even complex landscape into a fortified point. The dimensions of the camp were strictly regulated. For a full legion of 6,000 soldiers, an area of approximately 600 by 400 meters was allocated. This space was enough not only for soldiers but also for their transport, supplies, animals, and siege engines. As a result, the legion received a fully autonomous fortified city that could be erected anywhere in the empire. The fortifications around the camp were built according to a single pattern. First, a ditch about 1.5 m deep and up to 3 m wide was dug. An embankment 2 m high was piled from the excavated earth, on top of which a palisade of sharpened stakes was erected. Thanks to this, the camp became a complete defensive structure, capable of withstanding a surprise attack and holding back even significantly superior enemy forces. For barbarian tribes accustomed to open battles and swift raids, such fortified positions were an insurmountable obstacle. The internal structure of the camp was characterized by ideal order. The praetorium was located in the center, where the commander's tent and headquarters were situated, from which troop command was exercised. Main streets radiated from the praetorium, dividing the camp into equal sectors. This order was maintained for centuries. Gates were located strictly in the center of each wall, and were named according to their direction, main, rear, and side. Such a standardized scheme allowed a legionary, even when entering an unfamiliar camp, to easily orient himself and find his place. The process of camp construction was meticulously planned, and each century had clearly defined tasks. Some dug ditches, others erected palisades, and others were responsible for arranging internal roads and setting up tents. Everything happened smoothly, without fuss or disorder. The creation of a complete fortified camp took only 2 to 3 hours, and by evening, the marching column had turned into a protected fortress. Tools for these tasks were part of the standard equipment. Legionaries carried not only weapons, shields, and armor, but also shovels, picks, axes, and saws. In addition, there were specialized engineering units with more advanced equipment that helped solve particularly complex tasks, such as reinforcing parts of the rampart, building bridges, or constructing siege engines. The logistics of the castra ensured the full independence of the legion. Inside the camp, there were kitchens, workshops, food and weapon storage, hospitals for the wounded, and stables for cavalry. All this made the legion self-sufficient and independent of local resources. The army could remain in one place for weeks, without an urgent need for resupply. The defensive power of the camp significantly increased the combat effectiveness of the legion. Even a numerically superior enemy could not take the camp by storm. Attempts at assault invariably led to heavy losses and demoralization. At the same time, legionaries felt safe and could rest peacefully. knowing that they were surrounded by a fortress built with their own hands. Standardization of camp design became an innovative solution. It simplified troop command, increased discipline, and created a sense of stability and predictability. In any situation, a legionary knew exactly where his comrades were: the commander, the kitchen, the storage, and the hospital. This accelerated organizational processes and increased the army's combat effectiveness. Archaeological discoveries across Europe confirm the widespread distribution of Roman camps. Castra with similar layouts have been found in Britain, Germany, Gaul, and the Balkans. Some of the initially temporary camps eventually transformed into permanent fortresses and then into cities. The tactical significance of Castra was enormous. In offense, the camp served as a starting point for attacks and a command center. In defense, it became an impregnable refuge, capable of holding back superior enemy forces. During sieges, the fortress of Castra served as a deployment site for catapults and ballistae, as well as a reliable refuge for troops conducting protracted operations. The principles of rapid fortification, unified planning, and autonomous logistical support applied in the design of Castra are still used by armies worldwide today. The evolution of Roman camp structures spans centuries. Initially, camps were built of wood and earth ramparts, but over time, they were replaced by stone walls and towers. In civilian areas, many of them turned into permanent defensive structures. The basic postulates remained unchanged: order, standardization, and speed of construction, which made the castra one of Rome's most effective, albeit invisible, tools. The seventh and perhaps most impressive Roman achievement in warfare was the creation of the Testudo formation, or tortoise. It turned legionaries into a mobile fortress, invulnerable to a hail of arrows, javelins, and stones. Unlike the dense phalanxes of other armies, the Testudo combined defense, maneuverability, and a powerful psychological effect, becoming a symbol of the strict discipline of Roman troops and their ability to act as a single entity. At the core of this formation were large rectangular shields, the scuta. Soldiers were arranged so that their shields covered them from the front, sides, and top, forming a dense defensive structure. Within this shelter, legionaries could advance safely despite enemy fire. No other army in the ancient world possessed such an effective method of defense against projectile weapons. The front ranks held their shields vertically, the side ones protected the flanks from attack, and the soldiers from the depth of the formation and the rear ranks raised their shields above their heads, creating an impenetrable roof. Each soldier provided protection not only for himself but also for his neighbor. The size of the formation varied depending on the task. Small tortoise detachments, consisting of several dozen men, were used for reconnaissance or stealthy approaches to targets. Larger groups, numbering from 100 to 200 legionaries, covered siege engines, scaling ladders, or engineering structures being built. The shields formed a reliable armor. Arrows and javelins bounced off harmlessly. Stones and logs rolled off the inclined surface. Boiling oil and resin flowed down, causing no harm to the legionaries protected beneath. Mobility was limited. The speed of movement was about 3 kilometers per hour, but this was quite sufficient for approaching fortifications and for assault operations. The formation could move over complex terrain and climb slopes while maintaining its integrity. Any disruption of order made it vulnerable to the enemy. The tactics of using the tortoise were diverse. During sieges, it was used for covert approaches to fortresses. In open battles, for protection from archers and catapults, and also as a psychological weapon. Enemies, seeing the slowly advancing solid wall of shields, lost morale. For the legionaries themselves, the testudo was the embodiment of a single, invincible organism. Arrows and stones bounced off, and the Romans advanced step by step towards their goal. Training in the testudo formation began from the first days of service. Recruits were trained to join shields, move in unison, and maintain formation under all circumstances. Only through this level of discipline could the tortoise be effective. No army of antiquity could have reproduced this formation with such effectiveness. It required complete subordination of each soldier to the collective rhythm. The historical significance of this formation is colossal. It clearly demonstrates that the might of the Roman army lay not so much in individual bravery as in collective discipline and unprecedented organization. The tortoise served as a source of inspiration for future armies and is still used today in similar defensive formations, for example, for riot control or in urban combat. This weapon was organically developed by the very structure and discipline of the Roman army. It allowed legionaries to unite into a single entity, forming a living wall practically invulnerable to enemy attacks. It was precisely thanks to the tortoise tactics that Roman infantry was able to conquer cities and fortresses that had previously been considered impregnable. The 7 types of Roman weaponry we have examined changed not only the tactics of individual battles, but also influenced the entire course of world history. Without these technical and engineering solutions, the Romans could hardly have conquered half of the known world at the time and created the greatest empire of antiquity, which left its mark for a millennium. Each of these inventions represented a revolutionary step in warfare. The Gladius transformed close combat from a chaotic melee into a precise and methodical science of destruction. The pilum shattered the traditional tactic of shield walls, rendering enemy defensive formations useless. The scutum provided legionaries with reliable protection, turning infantry into a mobile fortress. The ballistae for the first time provided armies with the ability to engage in precise and powerful combat at long distances. Catapults allowed the destruction of even the most impregnable fortifications, turning siege operations from a months-long grueling struggle into relatively quick actions. Standardized field camps, the castra, provided the army with autonomy and reliable protection anywhere in the empire. Finally, the construction of the Testudo made Roman infantry virtually invulnerable to projectile fire, allowing them to assault even the most heavily fortified positions. But most importantly, the power of Roman weaponry lay not only in the iron and wood from which it was made. Its success was based on a systemic approach. Each type of weapon perfectly complemented the others. Swords were used in conjunction with shields, and pila gave gladiators an opportunity to attack. Siege engines functioned under the cover of soldiers, and fortified camps ensured the army's safety and uninterrupted supply. This entire combination formed a comprehensive military system significantly superior to the simple sum of its elements. Roman engineers and armorers combined craftsmanship and science in their activities. They studied physical laws, applied fundamental principles of mathematics and geometry, and conducted experiments with various metals and woods. Roman metallurgy and mechanics reached the peak of ancient engineering, and their inventions became the foundation for subsequent civilizations. Another element of their success was mass production. While barbarian tribes produced weaponry individually, Roman arsenals produced thousands of gladii, shields, and spears. All of them conformed to unified standards and quality. Such standardization ensured the army's uniformity and high reliability, becoming its hallmark. Training in weapon handling was also based on scientific approaches. Legionaries did not just master the art of war, they trained using strict methodologies, practicing movements for hours and perfecting blows to automaticity. This transformed ordinary farmers into highly skilled professional warriors who acted as one. The Roman Empire did not fall due to a loss of the ability to wage war, but rather due to the obsolescence of its military technologies. Barbarians adopted Roman weaponry, studied Roman tactics, formed their own armies on the Roman model, and directed the empire's might against itself. The lesson learned from Roman military superiority remains relevant today. In the modern world, victory belongs to those who have mastered technology better, organized production more effectively, and trained personnel qualitatively. The principles that ensured Roman dominance in antiquity remain effective in the 21st century. What Roman invention do you think was the most revolutionary? Do you believe the Romans could have achieved victory without their technological advantage? Which modern military technologies can be compared to Roman ones in their historical impact? Share your thoughts in the comments.